You're welcome back once again to this section. So in today's video, we are looking at stationary points and the nature of a curve. So if you are new on this channel, please go ahead to smash the like button of this video and share with your friends so that we can all get engagement on this channel. So thank you once again for joining today's live session. It's been a while coming your way to assist you in this form. So thank you once again for joining this section. So let's share, invite friends to join this channel so that we can all study together and get cleared of our doubt with stationary points and nature of curves, those issues that we need to touch on so that we are good to go. So keep sharing and then inviting friends to join, and make sure to like this video so that we can get engagement on this channel. Thank you once again. So let's get started. We are going to talk about stationary points and nature of a curve. So to start with that, first you are saying that a curve is of the form y is equal to ax squared, that's with the power of 2 plus bx plus c, that's in a more quadratic form, right? So the curve we're going to discuss in today's section is going to center on three things. We're going to talk about a maximum curve or maximum function. All right, we're talking about minimum curve or minimum function. Then we're talking about an inflection functions or curves. I hope that is clear, right? So we are saying that for you to have what a maximum function or maximum curve, at this point we are saying that the coefficient of what x squared here, the coefficient of x squared here should be less than what 0. Is that okay? So when you're talking about maximum function, for you to know that this curve is a maximum function, you are saying that the coefficient of what x squared, which is a, should be less than what 0. So there is the concept about what maximum. If it is minimum, we are saying that the coefficient of x squared here, a, should be greater than what 0. And if it at inflection, we are saying that the second derivative of the function, right, let's say x, should be equal to what 0. So that's what we are talking about when it comes to maximum function or maximum curve, minimum function or minimum curve, and the inflection. I believe that is clear. So always a curve is of the form ax squared plus bx plus c. That's in the form of what a quadratic. Okay, and for you to know is a maximum function, we are saying that the coefficient of a should be less than 0. If it is minimum, we are saying that the coefficient of what a should be greater than 0. With the inflection, we are saying that the differential, the second derivative of the function, should be equal to what 0. So that's what we mean by what the curves that we're going to discuss, the maximum and the minimum. So when it comes to determining their stationary points, it is a point where the curve changes its direction. Stationary point, I'm talking about points where the curve changes its direction. I hope that is clear. So at that point, when you get to that point, the curve doesn't move anymore. Assuming that the curve is in motion, it's in movement, the curve doesn't move anymore. That's what we call the stationary. We can also call it the turning point. The turning what point. So now let's start with the maximum function. So if I have a maximum function, this is how maximum functions look like. So let's say I have my gradient line in this form. So this line I can call it as x equals, let's say what, a, as my gradient line. Okay, we are saying that for you to have what a maximum function, going to be in this form, something like this. So this is what a maximum what curve or maximum what function. I believe that is clear. So at this point, we can say that if this is a maximum curve, then you should have your coefficient of what a, so the coefficient of x squared should be what less than what 0. So I can say that this function can be y to be equal to negative a x squared plus bx plus what c. Because at this point we know that a is less than what 0, because a is what negative what a. I hope that. So this is what a maximum curve. So we are saying that when it comes to maximum, in determination of what the maximum what curve, maximum curve here, and then the stationary point for this maximum curve, we are saying that this line is what my gradient line. This line is my gradient line. Let's say line what AB is my gradient line. When this gradient line touches this point, we call it what at the point of what tangency, or at the point of what tangent. How that is clear. And it's at this point that we determine what we call our turning point or stationary point. It's at this point where we determine our turning point or stationary point. So we are saying that for you to determine the stationary point or the turning point, let's say we are moving from here, let's say at point x, right? You are moving from point X. So if you are moving from point X, we will move at the top here and we move on and on and on and on. And when we get to here, remember here, when you are moving from point X to the stationary point, you are moving from what, to the negative side of this curve. You are moving from the negative side of this curve. So you are moving, so at any time you are moving from the negative side of this curve, right, sorry, that's negative side, or the left side I mean, to the right, you can clearly see it has a relation like this, right? It has a relation like this, an upward what curve. Is that okay? So when you see any curve of this form, we are saying that at any time you find the gradient of such curve is going to result to what, positive. So gradient here is going to result to positive when you are moving from the negative, sorry, the left side of the curve to the turning point, going to result to positive. So when you get to the turning point here, and when you descend down, it becomes something like this. The curve becomes something like this, and at this point, the gradient becomes what, negative, negative at this point. So when you move from left of this maximum curve to the point, let's say here is y, to the right side of this maximum curve, the signs, or the signs here involved, changes from positive towards negative. So when you ascend, it is positive in terms of the gradient. When you descend, in terms of, is what, negative from the turning point to the left, to the right, sorry. So here we are moving from left towards right, and we are saying that this curve, for you to know that is what, a maximum curve, is going to, your line, I mean your gradient line, is going to be on top. In other words, the curve is going to be below the gradient line, where it will touch at the point of the turning point, or tangency. So for you to know that this is a maximum curve, you're gonna have your curve line below the gradient line, as you can see here. So you can see that this curve line below what, gradient line, what, AB or BA. I believe that is so. That is what we call what, a maximum what curve. That's what we call a maximum what curve. So let's take note of that. And when you are moving from left to right, the gradient changes from positive towards negative. So let's take note of that. So that is the maximum what curve. So when it comes to the minimum curve, is actually the opposite. So with this maximum curve, we can call it a converse what curve. You can call it a converse curve. You can call it what, a converse curve. So let's get back to the minimum function 2. So minimum function 2, you're gonna have your straight line like this. So your straight line going to be something like this, right? Where you have your x equal to what, a. This is your gradient line, okay? And you're gonna have the curve being sitting on the gradient line. So at this point, you can call this point the turning point, or the point of tangency. I hope that is clear. So in that line, let's say I also have here to be a, and let's say at the turning point to be b, and here to be c, right? So here to, the idea is that I'm moving from what, left to what, right, okay? So if it is a minimum curve and I'm moving from left to right, or let's say I move from point A to point B, remember it's going to be a curve of this form. It's like more like an economic curve, going to be a curve of this form, a downward curve. I hope that is clear. So when you have a downward curve like this, at this point, when you find the gradient, it's always result towards negative. So the gradient is going to what, negative what, m. I'm representing the gradient as what, negative m. So it's going to be something like that. I'm coming out to delete. So here you're going to have what, a negative what, m. So once you move from A, if you are moving, I mean if the curve is moving from point A to point B, where you have the turning point, you're going to be negative. But then from the turning point to this point is going to be what, positive. So if you are moving from left to right, it changes from negative to what, positive in terms of what, the gradient. I hope that is clear. And we call this the turning point, or the stationary point. At this point, the curve is neither moving. At this point, the curve is neither moving. It's just become motionless at that point. It doesn't move anymore. So I hope that is clear. So that is what we call what, a minimum curve. And you are saying that with a minimum curve, for you to know that this is a minimum curve, it is always going to be sitting on the gradient what, line. That is going to lie above what, the gradient what, line. And you can see with the maximum curve, it's lying below the gradient what, line. So let's take note of that. So that is the nature of what, a minimum function or minimum what, curve. That's the nature of the minimum function or minimum curve. And as we have already indicated here, we can call this the turning point, or the stationary what, point. Any name that you want to give it to it, you are good to go. And when it comes to the point of inflection, this is how inflections look like. let's say I have a gradient of this form, gradient x, sorry, a line xy, line xy, right? Now when we talk about point of inflection, this is how it look like, the nature of point of inflection. Gonna have something like this. Point of inflection gonna have something like this. So when it comes to the point of, let me draw it all for you. Oh, sorry. So it's going to be something like this, straight and in that form. So when it comes to the point of inflection, like let's say with gradient what, or line xy as being our gradient. In this case, once you see this, we are saying that at this point, we call this point at the point of inflection. Why? Because this curve is look like having some of its part looking like a maximum, where you can see from here, from this side, right here, more like it wanted to become a maximum curve, but then it gets to this point, the line flat with the gradient line. And then this one to also have the same feature like a minimum, wanted to start like this, and then a line flat at this point. I hope that is clear. So when you see this nature of this curve, we call it what, an inflection what curves. We call it an inflection what curves. So an inflection curves, at that point the second derivative of this function is always equal to what, 0. Is that okay? So that is an inflection what curve. That is an inflection curve. And when it comes to an inflection curve, whether you move from left to right or right to left, their signs remain the same. From left to right, you're gonna have what, positive positive, or you're gonna have what, negative what, negative. So whether you move from left to right or right to left, the sign remains the same. It's going to be that positive positive or negative negative. I mean, you won't have one point from left to right to be positive and one to negative. No, that won't happen. But when it comes to inflection, it is either positive positive or negative negative in terms of movement from left towards right. So that's what we call the point of what, inflection. At least a brief idea, but to know what we are actually talking about. So that's the whole idea when it comes to the nature of the curve that we want to understand from this case. So I believe you are getting values. So you are getting values, please make sure to smash the like. If you haven't liked, and subscribe to the channel so that you can get more assistance to this channel. So that is the nature of what, a curve. That is the nature of a curve. So as I've indicated here, this one we can call the converse. I think I'll talk about it. But with the minimum curve, we're going to call it what, the concave what, curve. You can call the concave curve, and you can also call the maximum as what, converse what, curve, right? So let's take note of that. So in summary, if I have my Cartesian plane x and y, if I have my Cartesian plane x and y, let me have it here. Let's say this is my Cartesian plane x and y, and I have a curve of this form, a curve of this form, a curve of this form, let's say, and like this. Let's say I have a curve of this form. We can clearly see that at this point we have what, a minimum what, we can call this as what, our maximum turning point or stationary what, point. We can also call this our minimum turning point or stationary what, point. I believe that is clear. Likewise here too, you can also call the minimum turning point, stationary point. We can call here to be at the point of what, inflection. You see, you have that nature like something like this. Let me use the red to indicate it. You see the line just chopped small off here. It wasn't what, elongated, so it was just small here at this point. So we can call this what, at the point of inflection. I hope that's clear. Likewise, this one too can also be called at the point of what, inflection. So let's take note of that. So inflection points in that line. So at that point we are saying that the second derivative when you differentiate is equal to what, 0, right? Sure. So with this one, when you use the quadratic approach, we are saying that if it is a maximum curve, then you expect that your coefficient of x squared should be less than 0. If it's a minimum, we are saying that the coefficient of what, x squared should be greater than what, 0. So that's the general thing you want to know. In other books, you might hear of what we call global maxima, global minima, and those kind of names. These are the names that we can actually use for to depict these diagrams. I mean, based on the materials you're using or your school of thought, you can have those names, but then they all mean the same thing. So let's take note of that. So this is how we determine the nature of a curve, whether it's a maximum curve, a minimum curve or at the point of inflection. So if there is any question, please let me know in the comment section to know how I can assist you in that case. If there is no question, then we are taking on to our first example and determination of what conditions necessary for to determine our turning point and then to determine the nature of what the curve in that case. So let's take our first example. We are asked to find what the stationary point and to determine the nature of this curve. Y is equal to x cubed minus 6x squared minus 15x minus 2. So we are asked to determine the nature and stationary point for this what curve. So how do you go by the determination of this, the nature and the stationary for this curve? So in doing that, let's see how we go through this. What we did here was just to determine the nature of the curve, but we're going to go through how we also engage on in the determination of what the stationary points or the turning points of these curves. So please stay here carefully with me so that we get to understand how we go through in that case. And make sure to like, if you haven't liked it, share with your friends. Let all join us to learn in that case. I hope that is clear. So let's take note of that. Alright, so let's see how we can go through with the determination of what the stationary points of what this curve. Now, for you to determine the stationary point of a curve, remember this in a form of a cubic word function. So a cubic function is a combination of what maximum and minimum curve put together. That forms what a cubic word function. So at the end of the day, when you go through to determine the stationary point, to determine the stationary point of this curve, you're gonna have two turning points, one be a maximum curve and one being what a minimum curve. So please put that at the back of your mind that at the same time you have a cubic function, is going to result to a minimum turning point and a maximum turning point, irrespective. If it is cube, that's how it's going to be. So let's take note of that. So now we are asked to find the stationary point of this curve and the nature for this curve or this function that we have here. So first thing that you want to do when you want to determine the stationary point of any curve is the first thing is to find what the derivative, the first differential of that curve. Find the first differential of that curve. So in find the first differential of that curve, here we are having y, this variable, we're having y and x into play. So I'm going to say that the first derivative is going to be differentiate y, differentiate what x. I hope that is clear. So at this point, I want to differentiate what x cubed is going to result to what 3x squared. So here, once you know the base of differentiation, just write it straight away, then you're good to go. And then it comes here, when you differentiate 6x squared, it's going to result to what 12x. When you differentiate 15, it's going to result to 15. We said the differential of a constant value is going to result to 0, so you don't waste your time to write it. So this becomes the first differential of what y is equal to x cubed minus 6x squared minus 15x minus 2. So once you have your first differential down, the next thing you want to do is to find the value of the x at the first differential. And to find the value of x at first differential, we are saying that at the turning point, your dy over the x is equal to 0, because y at that point the curve is no longer moving. So we are assuming, or we are sure that the work of the curve remains was 0. The work of the curve remain was 0. I hope that is clear. So at the turning point, we are saying that the curve remain motionless, doesn't move anymore, it just stopped there. So once it stopped there, the idea is that the curve is no more working. So if you're not working, let's say you're a human being and you don't go to work, will you get money to afford your living? No. So you're going to get a 0 what money, and at that point, since the curve is no longer moving, it's going to result to what 0. So that's why I can always be saying that the first differential should be equated to what 0. At that point, the curve is no longer what moving. So let's take note of that. So at this point we can say that our dy over the x is going to be equal to what? 0. So we say that at dy over dx is equal to 0, we can say that therefore I can bring it down here. Let me bring it down here. We can say that our 3x squared minus 12x minus 15 should be equal to what? 0, right? So once you're able to find it, so here with the help of a calculator, you should be able to solve for this. So if you want to solve this using calculator approach, you switch off your calculator, you go to mode, you select 5 and you select 3. You're going to have something like this: ax squared plus bx plus c. And you're going to have what? Once you hit on, you're going to have 3 boxes appearing on your screen. And then these boxes, one stand for a, one stand for b, one stand for c. The a is the coefficient of what? X squared. The b is the coefficient of x, and the c is the constant. Just key in these coefficients and the constant value, and you're able to get your answer for this equation. So with my case, I had x plus 1 and I had x minus 5. That's what I got for this. So at this point we can say that x is going to be equal to -1 or positive what? 5. I hope that is clear. So once you get these values down, is that this value are going to use to test for the nature of what this curve, whether it's a maximum or minimum or combination of the two. I hope that is clear. So let's see how we can test for it. So in testing for the nature of the curve, you continue to find the second derivative of the function. So in doing that, I'm going to find the second derivative. So in find the second derivative, we're saying that we differentiate what? The function at the second time. So that's why you see what? The squared here means at the second time. So the squared y over what? The x squared. Is that okay? So that is what we are going to look at. So we know that our first differential was what? 3x squared minus 12x minus 15. Is that okay? So at this point, I'm going to differentiate it what? Again. So when you differentiate 3x squared, is going to result to what? 6x minus, when you differentiate 12, is going to result to what? 12. You have that one here. When you differentiate what? 15 is a constant, is going to result to what? 0. So there is no need for you to what? Write this kind of what? Constant what? Value in terms of the result that we are applying using the differentiation rule. I hope that is clear. So at this point, once you get to this point, it is at this point we're going to use the values of x to test whether the curve is a maximum, minimum, or combination of what? The two that we are talking about, even at the point of what? Inflection. I hope that is clear. So let's take note of that. So here, this is what you're going to do. You just pick up the first value at x is equal to what? -1. What is going to be your d squared y over dx squared? So at this point we can say that my d squared y over dx squared should be equal. So whatever you see here, just substitute -1 there. So it becomes 6 into bracket -1 minus 12. I hope that is clear. So here I'm going to get what? -6, -12, and that's going to give me what? -18. So you can clearly see that -18 is less than what? 0, isn't it? And this point becomes what? A maximum what? Point, or maximum what? Function. So once you're able to determine that this is a maximum what? Point or maximum function, then when you substitute the -1 to the original equation, the value going to derive as y together with the x is going to be your maximum point, or the turning point for a maximum curve. I hope that is clear. And you do same with the 5. So let's see with the 5. So at x is equal to what? 5, we can say that our d squared y over dx squared should be equal to, so just substitute whatever you see, substitute 5 there. So it's going to be 6 into bracket 5 minus what? 12. So at this point I'm gonna have what? Here to be 30 minus 12, and here is going to result towards 18. I hope that is clear. So you know that 18 is greater than what? 0. So since 18 is greater than 0, meaning that here is what? A minimum what? Curve, or minimum what? Point, in terms of what? The function, and in terms of the stationary point. I believe that is clear. So let's take note of that. So once you're able to get these values down, then you're going to tell us that once x is giving you maximum and then 5 is giving you what, a minimum, you just substitute these values into the original equation so that you find the values of what, y, for these what curves that we are talking. So this was the original equation that we were given in the question, right? So I'm going to bring it down here so that we find the values of y with respect to these what curves. So I can say that y was equal to x cubed minus 6x squared minus 15x minus 2. So at x is equal to -1, which we established that should be a maximum point, is going to be, so y is going to be what, whenever you see x in the original equation, just substitute that value in there. So it's going to be -1 cube 6 into bracket -1 squared minus 15 into bracket -1 minus what, 2. I believe that is clear. So at this point, if you have a calculator, just simplify straight away and you get your final answer done. So with my case, I had y to be equal to what? I had y to be equal to 6. That's what I got for this curve. I have y to be equal to 6 as a point on the maximum what function or maximum curve. So I can say that my maximum point is going to be -1 and what, 6. It's going to -1 and what, 6. I believe that is clear. So that is my maximum what point. And then you come and do same for the 5. So at x is equal to 5, that's where we said that the 5 should represent what, a minimum point is going to be. So you're gonna have here y to be equal to y to be equal to y to be equal to y to be equal to, so just substitute 5 into the expression. So it's going to be 5 cube minus 6 into bracket 5 squared minus 15 into bracket 5 minus what, 2, and you are good to go. So calculator work and then get your final answer down. I hope that is clear. So at this point, with my case, I had an answer of -102 as the value of y when you substitute what, x. So at this point, I can say that my minimum what point, or my minimum turning point for this curve is going to be 5 and what, -102. So that's what I got for my minimum point, and then my maximum point was -16 and my minimum point. So always when you talk about point, it should be in a coordinate of x and y form. I hope that is clear. So this is how we determine what, the nature. So we can say that the nature, based on the point, we can say that you have what, the nature of this curve is a combination of what, a maximum and minimum what curve being put together. That forms what, a cubic what function. That forms this cubic function that we are seeing here. I hope that's clear. This could be what, curve. So let's take note of that. So this is how we determine the nature of what, the stationary point of a particular curve, and the nature of the curve actually involved. So let's assume that at the end of the day, when you find the second derivative, right, when you find the second derivative and we substitute the value, we're getting what, 0. So when you're getting 0, then it will mean that that point is what, a point of inflection. At the point of inflection, we are saying that the second derivative squared y over dx squared should be equal to 0, or f double prime of x should be equal to 0. Please let's note this before we continue. In that case, if you are telling us that this is a second derivative or this is a first derivative, we are saying that our dy over dx should be the same thing as what, f prime of x, right? Our d squared y So this is why we are saying that our d squared y over dx should be equal to what, f prime, and then we have the second derivative, the same thing as what, f double prime, and it continues on and on and on. So if you don't see the y over dx, you're gonna see what, f prime. If you don't see the squared y over x squared, you're gonna see what, f double prime. So that is how actually this actually works. So let's take note of this so that you know how to work along in that case. So let's take note of that. So this is how we determine the nature of the curve, right? And then the stationary point and the nature of what, the curve. So if this was really helpful to you, you can go on to smash the like button, make sure to subscribe to the channel and share with your friends. So in summary and in simple short, we are saying that for you to know whether a curve is a maximum curve, in terms of moving from left to right, it changes from positive to what? Negative. And then at the turning point is where the curve doesn't move anymore. At that point, your gradient is equal to what? Zero. Your gradient is equal to zero. That's your first derivative. Is that okay? And with the minimum, we are saying that the curve will be sitting on the gradient line, or the curve will be above the gradient line. And at that point, your turning point or your stationary point remains zero, because at that point the curve is no longer what? In motion. It's at zero, so it doesn't work anymore. So at that point, your stationary point, sorry, your gradient at that point is go towards zero, and you can find your stationary point. And we said that if it's an inflection curve, then at that point your second derivative should be equated towards zero. And that's what we are talking about. We said that the minimum curve can also be called the concave curves, and the maximum curve can also be called what? The converse what? Curves. So that is what we are actually spoke about just some few minutes what? Ago. So that is how we go by to determine the stationary point and the nature of a curve. So that is that. So if there is any question, let me see in the comment section, or if you missed this live session, you can put in the comment section of this, so I will come back and then respond to this question. So thank you once again for being with us. So we also have another live session you're going to treat on that is I think this evening is 6, I think it's 6 p.m. or so. I think I've forgotten that, but then it's at the evening. So make sure that you also visit this channel to come and watch that video once again, so that you all get engaged on this channel. So I'll see you in the evening, where we also discover the applications of differentiation in that case. So I'll see you for now. Bye bye.